Well, good evening, class. All right, this is Pre-Algebra, lesson 4.7, and we are going to look at base 10 and other bases. And so really we're going to use our base 10 system to try to understand how other base systems work. All right, base 10 and other bases. All right, so if you're looking at your notes, it starts off this way. Our number system, the decimal system, the decimal system, is a base what system? Do you know? It is a base 10 system. Our decimal system is a base 10 system. And here's an important aspect. The system will have as many digits as its base. The system will have as many digits as its base. So our system has how many digits? And of course, we all know that that's 10, right? Our system has 10 digits. If you were to write the digits, of course, you would write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? We have 10 digits, the 0, and then the other 9 digits, a total of 10 digits. B, the value of a number is the sum. Is the sum of the product, and what two things are you doing? Each digit and its place value multiplier. So the value of a number is the product of each digit and its place value multiplier. Okay, so what does that do then for the number 5,432? Well, if you were going to try to sum up the digits, you have to multiply each digit by its place value multiplier. The 5 is in the thousands place, right? So that's times 1,000. The 4 is in the hundreds place, so that's times 100. The 3 is in the tens place, so that's times 10. And the 2 is in the ones place, so that's times 1. Makes sense, right? So if we were to add this number up, we would get 5,432. All right, well, let me go ahead and get that going here. So 5,432, right? So the place value multiplier can also be represented in exponent form with a base of, okay, what is our system in? What base? Base 10. So because our system is a base 10 system, the place value can be represented with a base of 10. Can be represented with a base of 10. All right, so look back up above. You got 1,000, right? What is 1,000 with 10 as the base and the proper exponent? Well, that's 10 cubed. What's 100 with a base of 10 and the proper exponent? 10 squared. What is 10? 10 to the first. And how do you get 1? 10 to the 0 power. So when you're writing these for our other bases, in actuality, what you're going to do is you're going to start on the right. Right? So when you write them, you're going to start here and go 10 to the 0. Okay. What's next? First, second, and third. And that's how you write your place value multipliers. Pretty simplistic, but that's the key to everything. So we got the asterisk there. We got that boxed in. This is really how you're going to be able to do other systems. Okay, so what's the first one we want to talk about is a quinary system. Quinary. Sounds like a medicine, quinine or something. All right, quinary. The place value multiplier is in exponent form in this system, and I'm going to use my green here, have a base of 5. So the base in a quinary system has a base of 5. Okay, so let's think about this. How many digits would a quinary system have? Well, go back up and look on your sheet, and you look at A, and it says the system will have as many digits as its base. So a quinary system has only how many digits? 5 digits. All right, let me get this back in orientation. So only 5 digits. So what would those digits be? Now you need a 0, so 0 is the first one. Then you got a 1, you got a 2, you got a 3, and you have a 4. And here's the weird thing. Base 5 quinary system does not have the digit 5 within it. Not in its digits. It does for a base, but not in its digits. That's just the way it goes. Okay? All right, so let's take a look at this quinary system. A little bit of notation here. And if you look over here at the right there, you have the number 234 with a subscript 5. The subscript of a number indicates the base of that number system. So that subscript indicates the base of the number system. So 234 in base 5 is what this represents. So what is that? That's the number 234. And you really shouldn't even say 234 because it's the number 234 in base 5. All right, let's see how we do this. All right, so if you look down below here, I've written the place value multipliers. So again, remember, we always start on the right, and we got to do 5 to the 0 power. What's its value? Its value is 1. All right? Then you go up, 5 to the first power. What's its value? 5. So again, the multipliers are on the top, and the value of the multiplier is right below. 5 squared is next, which is 25. 5 cubed, 5 times 5 is 25, times 5 is 125. 5 to the fourth would be 125 times 5, that's 625. 5 to the fifth is 625 times 5, or 3,125, etc. Depending upon how big the number is, you may need more. We're not going to do numbers that big. Okay, well, this is the key to the whole system, is understanding the base. Okay, so D says this: find the base 10 value of 234 base 5. So we need to write in our place value multipliers. So again, start on the right, and we're going to go 5 to the 0. Next, moving to the left, is 5 to the first, and then 5 squared. Okay? 5 to the 0, all the way to the right, then 5 to the first, then 5 squared. Next, we're going to do the actual value. And it doesn't matter which way you go on this one. 5 squared we know to be a 25. 5 to the first, a 5. And anything to the 0 power is... Do you remember why anything to the 0 power is 1? All right, quick review. Remember, the 0 power is the base divided by itself. It's the base divided by itself. So what is 5 to the 0 power? 5 divided by 5. And anything divided by itself is 1. All right, so anyhow, we've got a 1 there. Okay, let's continue on now. Now let's get the actual value. 2 times 25, 50. 3 times 5, 15. And 4 times 1 is 4. Okay, add them up. Add them up, and you now have the value. And what is 234 base 5 in our base 10 system? It's the number 69. That's the way it works. Let's do another one. All right, so this time we have the number 21445 base 5. 21445 base 5. And let me get this higher up on my screen. Okay, so we're going to start the exact same way. Can you do it? Pause the tape right now if you want to do it yourself, and we'll come back and see if you've got it correct. Okay, so again, start to the right. 0 is first. 1, 2, 3. Let's figure out those values. Right to left sometimes works better. This is a 1. It's a 5. 5 squared, 25. 5 cubed, 125. Okay, and hopefully you finished it off correctly. This is a 250. This is a 25. This is a 20, and this is a 4. So 250 and 25 is 75, 85, 95, 299 is the number 2144 base 5. It's actually the number 299. All right, interesting, huh? I think so. Okay, let's look on the back of your sheet there. In a binary system, okay, we just did quinary base 5. What would a binary system be? Well, if you know about prefixes, you've got a clue right there. What does that prefix bi mean? Well, you guys know. You know, when you were so old you got a bicycle, and we all know that bi is 2. So the place value multipliers in exponent form have a base of 2. Binary system. Anybody know why in our world today a binary system is important? Anybody know? Why in today a binary system is important? Well, don't miss this, but computers are based upon a binary system. The electronics of a computer all work on the basis of a binary number system. Okay, so how many digits does our binary system have? The answer is only 2. That's it, 2 digits. What are they? Well, remember, you got to have 0, and therefore the other one is 1. In a computer, it would be on-off. Computers are all based on an on-off situation. It's either going to be an on or an off, a 0 or a 1. That's it. That's it. And that's how your whole computer, what you're watching me on right now, is all based upon a binary system in its core. Okay, so here are the place value multipliers of a binary system. Again, notice I always start on the right. And so 2 to the 0, anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. 2 cubed, 2 times 2 is 4, times 2 is 8. 2 times 8 is 16. 2 times 16 is 32. The next one would be 64, then 128, then 256. Do those numbers sound familiar? 64, 128, 256, right? Do those sound familiar? They should. 512. They are the way computer memory has advanced. All right, so binary, really important. Okay, so find the base 10 value of 101 base 2. All right, remember, we need to put in our place value multipliers. Start on the right and work towards the left. That's pretty easy. Start on the right, work towards the left. Okay, let's go ahead and now plug in what the value of each is. We know 2 squared is 4, 2 to the first is 2, and anything to the 0 power is 1. Let's go ahead and figure out our value. So this is the number 5. It takes a 101 base 2 to get the number 5. Seems like a lot of work for just the number 5, but that is exactly the way it goes. It does take that much work to get the number 5. Let's do another one. Here, let's look at 1110 base 2. How do you start? Place value multipliers, right? Got my digits all lined up. I'm going to sum them up, but I got to add in the place value multipliers starting on the right. Again, if you want to finish this off, go ahead and pause the video. And then after you're done, you can look back and see if you've gotten it correct. Okay, place value, 1, 2, 2 times 2 is 4, 2 times 4 is 8. Easiest way to do those. All right, what's our value? Got an 8, a 4, a 2, and a 0, 12, 13, 14. So it takes the digits 1110 base 2 to come up with the number 14. And any number can be derived at using this methodology. Okay, So I showed you a quinary system, base 5. I showed you a binary system, base 2. Let's see if we can do base 7. All right. Now remember, system has as many digits as its base. So how many digits would a base 7 system have? Okay, that's important. Remember to do the multipliers. They're the key to everything, starting from the right, working to the left. Okay, see what you can do with it. Again, I would pause the video at this point. Go ahead and work it out, and then you can unpause it and come back and see if you have it correct. All right, how would I do this problem? I would do the digits. Now I'm ready for my bases. 7 to the 0, 7 to the first, 7 squared. Now I'm going to need my values. 7 to the 0 is 1, 7 to the first is 7, and 7 squared is 49. Let's get our value. 98 plus 28 plus 6. So 98, 108, 118, 126 plus 6, 132. 246 base 7 is the number 132. All right, last thing we need to do is to go the other direction. So now we want to convert from base 10 to another base. So what did we just do a minute ago? We converted from another base, quinary system base 5, binary system base 2, and a system with base 7 into our system. Now we want to go from our system into their system. Okay, so it's a little bit different process. So first thing, put 34 into base 2. Okay. Well, we have to figure out the multipliers. So again, please understand the first one is always to the 0 power. And you got a second and a third and a fourth, etc. Well, how do you know how many to do? Well, you're gonna figure out a value close to this number. So here's what really happens, and maybe I shouldn't have used the word start there, but it's the starting of the division process. But here's the actual values, right? So as you're going along, as you do this 2 to the 0 power, you would say that's a 1. Then you would do 2 to the first, and you'd say that's a 2, right? And you're working your way across. Then you do 2 squared and say it's a 4. You do 2 cubed and say it's an 8. You do 2 to the 4th, 2 times 8 is 16. Then you do 2 to the 5th and say 2 to the 5th is 32. And once you said, hey, look at this, 32 is real close to my number, then you've gone enough and you're ready to roll. Okay? And I understand that's a little bit abstract. But again, when this number is close to the number that you're converting, then you've done enough bases. And if not, you'll catch it when you go to do the next step. What's the next step? Divide the actual value into the number. Divide the actual value into the number. So what did you do? You took your 32 and you're dividing it into the 34. Take your 32 and you're dividing it into the 34. So that's right here, right? And that's how you start. Okay, we all know how to divide 32 into 34. I'm going to do this in red. We all know it goes in one time. Now, if it didn't go in any, then you just start on the next number. If it goes in more than 10, then you chose the wrong number to start with. Okay, 32, we get a 2 remainder. Okay, how do you know what to do next? Take your remainder and stick it into the next division problem. How many times is 16 divided into 2? None. Again, that leaves us 2. How many times does 8 go into 2? None. It leaves us 2. How many times does 4 go into 2? None. That leaves us 2. How many times does 2 go into 2? 1. Remainder of 0. How many times does 1 go into 0? None. And that's our number. It's the number 1, 0, 0, 0, 1, 0, base 2. Base 2. Don't forget the base 2. 1, 0, 0, 0, 1, 0, base 2. All right, we've got one more left. We're going to take the number 773 and we're going to convert it into base 5. Now again, if you want to do this on your own, please pause the video, go ahead and try to work it out, and then you can unpause it and see how you did. Okay, the start. How do you start? You need the place value multipliers. 5 to the 0, right? It's always the first one. And I'm going to put underneath, that's a 1. 5 to the first is a 5. 5 squared is a 25. 5 cubed is 125. 5 to the fourth is a 625. Okay, now I'm in the ballpark, right? I think I've gone enough. I'm ready for my division. I'm going to take my 625 and I'm going to divide it into my 773. Okay, now this can be more than 1. It just so happens these first couple examples it was a 1. It could be any of the 5 possible digits. Okay, 625. That should be red actually. So 625. And what do we get here? 8 and a 4 and a 148. Okay, now we need the next division. 125. Take my 148. Okay, 125 goes into 148 one time. Could be more. It just so happens it's not. All right, what do I get? A 32. A 23. That was good. A 23. All right, let's do our next division. What's next? The 25. All right, putting our 23 in. All right, that one's a 0, right? Doesn't go in at all. Ready for our next one. What's our next number? A 5. What goes in? Our 23. 5 goes into 23 4 times. 3 remainder. We're ready for our last one. A 1 is our divisor, and we're dividing that into a 3, and 1 goes into 3 times. And of course, we should get a 0 remainder at that point. And hey, what's your solution? Here it is. 1, 1, 0, 4, 3, base 5, a quinary system. All right, let me do a quick review here with you and we'll be done today. All right, so remember it all starts off with our number system is a base 10 system, and remember the base matches how many digits you have. The base matches the number of digits for the system. What is the key to it all? It's these place value multipliers. These place value multipliers to give the value of the number. Talked about a quinary system. What's a quinary system? Base 5. Quinary system base 5. Remember, is 5 one of the digits for a base 5 system? No. It is the digit of the base, but it's not one of the digits of the system. Okay? 0, 1, 2, 3, 4, because you can only have 5 digits. Did a couple examples there. Then we went to a binary system, very important binary, because computers work on a binary system. It's going to be base 2. What is base 2? Base 2 is simply a factor of zeros and ones, right? What are those two digits? 0 and 1. How are you going to figure out the system? Start with the base to the 0 power and get its actual value and keep working your way across. And then we did a couple examples there. We even did an example of base 7. And then the last aspect is, how do you go now from base 10 into one of those bases? Again, what's the key? These place value multipliers. And this time it's going to take division to figure out the digits of this other base system. So we did the binary system first and got this value right here. And then we did a quinary system secondly and ended up with this value. All right, I hope that's understandable. Hey, it's on video now forever. You can come back many, many times and check it out. And we'll work on this in class tomorrow. Have a great night.